Fine, ma'am.
How are
Fine.
all others? Very good evening to all. Abhinav,
Good
Ayanija,
evening.
Sudhanshu, Zoha. All good?
Yes,
Yes,
ma'am.
ma'am.
Okay. So I think it's our first class of physics, right?
Yes, ma'am.
Right. So we are going to start with chapter light first. Okay. Uh, Related to this chapter, we already have learned in class 6 and 8, right? So basics, I think you people can tell me so easily. What do you understand by light? Raise your hands. Who can tell what is light? How does it help us? What is the role of light in our daily life?
Light is a form of energy which travels in a
Which,
rectilinear path.
which travels?
In a rectilinear path, like straight line.
Okay, good.
It helps plants to make photosynthesis.
Good. It helps plants also, right?
And
Hmm.
powers electricity like solar power. This one.
Okay, great, great, good. Yes, Triti?
Ma'am, it makes the objects around us visible.
Okay, it makes the world around us visible, right? Other students, there are still a lot many points that you people can tell me. In junior classes, we have learned a lot about light. Abhigya, Ayonija, Abhinav, Aryan,
Ma'am.
Roha, Sudhanshu. Okay, so well, correct that in the absence of light, we cannot see the world around us. So if I am able to see you people, if what will happen if I turn off the light of my room? You will not be
Visibility
able
will
to
get
see
low.
me, right? And you will not be able to see the things in our surrounding. Same. So it helps us to see the world around us. But light has a specific nature. It always travels in a straight line. Okay? It reflects and it has certain laws which are always followed. Doesn't matter where the light is traveling, right? So let me first share the screen. I hope it's visible to all.
Yes, ma'am.
Okay,
Yes, ma'am.
fine. So light is a form of energy which gives us the power of vision or produces in us the sensation of light. It always travels in a straight line, and this property is known as rectilinear propagation of light. Okay. Now next is reflection of light. The first and the basic law of light is that it reflects. Whenever light strikes at some surface, it bounces back by making certain angle, and the law we'll study further. Hold on. Read out this part and I'll show you how it happens. Yeah. So I'm redrawing this picture so that you can understand it. How does that happen? Suppose this is a flat surface, okay? The base part is the ground part, and the topmost part, this above surface, is the reflecting surface. Let's say that the light strikes the surface at this point. It's not becoming a straight line, please excuse me for this. So now this point where the light strikes the surface is known as, anyone? If you can tell me what is this?
Point of incidence.
Point of incidence. So if let's say if it is a wall, it is the floor, it is your curtain or any surface, right? This point where the light strikes is known as point of incidence. Next step is to draw a normal. Do you understand what is a normal?
The perpendicular dot to the surface.
Yeah, correct. So a 90-degree angle on any surface is known as a normal. We usually name it with the letter N, right? And now, what is the angle that incident ray makes with the normal? Is mistakes arises in many cases in many students that we measure the incident angle with the surface. But remember this point, incident angle is always measured with the normal. Okay, this is I. Next, the light will reflect back by obtaining certain angle, and again that angle is same, that is denoted by the letter R. So R is the reflected angle. Angle of reflection is R and angle of incidence is I, right? So the law of light says, look at this point. That angle I is always equal to angle R. Incidence angle will always be equal to the reflected angle, whosoever means wherever the light is striking, either the wall, the curtain, the paper, the table, the glass, means doesn't matter if the surface is smooth, however smooth it is, however rough it is, right? Next point says, this is the first law. Angle of incidence is always equal to angle R. Next point is the incident ray. This ray, let me choose another color, hold on. This is known as the incident ray, the ray which is striking on the surface, and the ray which is reflected is called the reflected ray, right? So incidence angle, the normal line, the perpendicular line, and the reflected ray, they all lie in the same plane. I must say that suppose that the light is striking along the screen of your laptop, along the screen of your iPad, along the screen of your phone, whatever, right? So that is two-dimensional screen. Get it? Now the light will be reflected back on that same plane only, on that screen only. So I'm talking about, let's say, two-dimensional surface. This means that incident ray, the normal line, and the reflected ray, they all lie in the same plane. Got it?
Yes,
Yes,
ma'am.
ma'am.
Right. So these are the 2 points. Just hold on. If you want to note it according to, means in your own language, you can. Okay. The 2 laws of reflection are that incident ray, the reflected ray, and the normal. At the point of incidence, they all lie in the same plane. And second is that angle of incidence is always equal to angle of R. So whichever activity you perform, whichever instrument based on the light you study about, these 2 laws will always be followed, right? So please note it down along with the diagram. Draw this diagram, okay, this one. And please mark incident ray, normal, reflected ray, reflection surface, and one point is missed here, this point of incidence. Mark this also. Children, I must say just one thing, that we are in class 10 now, okay? And the things sometimes go in detail a lot. So if we are getting lazy or keep like it's okay, kar lenge baad mein, or we will have notes or whatever. So don't do that. Note everything. You want to copy my notes, that's fine. If you want to write in your own language, that is also fine. Because later on at the exam time, what happened कि हमारे पास notes नहीं होते हैं, and we are short with the stuff to study and to revise. So then we become lost. Yep, क्या करना है? So better you make your notes properly. Noted?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
I'm getting the response from all. There are many students there. Keep responding, please.
Yes, ma'am.
Okay. So moving ahead. Yeah. I hope that all these points will be recalled very easily because we have already learned in class 8 also light. Sorry, it's 7. Next is a highly polished surface such as mirror reflects most of the light falling on it. Okay, now let me explain you a very small concept of highly polished surface and a rough surface, right? Okay, I'll take 2-3 names. You have to tell which out of these is a polished surface, or you can say smooth surface, and which is the rough surface. Curtain. The curtain.
Rough.
Rough surface.
Curtain is rough. Okay. Marble.
Smooth.
Smooth.
Okay. Wood. Polished wooden almirah.
Smooth.
Smooth.
Okay. Piece of paper.
Rough.
Rough.
Okay. Water spilled on the floor.
Rough.
Polished.
Smooth.
It's smooth. Okay. So how are we deciding that which surface is rough and which is smooth? Okay.
The
This
the
prior
smooth
experience.
surfaces.
Yes, please tell.
The smooth surfaces reflect light more than the rough surfaces.
Okay. And how do we decide basically any principle or what concept are you following for this? See, okay, listen, that when you touch a cardboard, okay, and on other hand, when you touch a polished wood, or you can say a polished marble, so what we feel that our finger is very easily sliding on marble, right? And the surface feel little rough on a cardboard or on a piece of paper. So the thing is that if we microscopically and minutely observe the two surfaces, we will find this unordered surface. In case of the rough surfaces, this can be paper, the wall, and the curtain means any fabric you can take. Whereas in case of marble, in case of a mirror, the surface goes like this. Hardly we find any irregularity in the surface. So such type of surface is considered as rough surface, and this type of surface is smooth surface, right? And examples of smooth surface are mirror. Mirror is the best example of smooth surface. Next is marbles, water spilled on the floor, etc. And rough surface can be any fabric, and you can say wall, you can say a paper. These all are rough surfaces. Got the concept? So the surfaces with minute irregularities will be considered rough, and the with the least irregularities will be smooth. What is the difference? That if we allow the light to fall on the two surfaces, the difference will only be in the reflection. Because of unordered surface, the normal means the perpendicular line is different on all at each and every point. So accordingly, our reflected angle varies. Are you getting? Sometimes the reflected angle is this, sometimes reflected angle is this. So overall, if we see the reflection of light on surface, on rough surface, we cannot find any image obtained. Whereas in smooth surface, if we allow, let's say I have drawn 3 rays of light, the surface throughout is plane. So at every point, the normal is like same, and the reflection angle will also be same. So because of the same reflected angle at each and every point, the all the light rays reflected back goes parallel, and due to this, we usually find image obtained in the smooth surface. Like sometimes in the mirror, a highly polished wood, or in the marble, we see our image. In mirror, means in mirror we can see a clear image, very clean, neat and clean image. But in other surfaces, it's little blur, but still the image can be seen, right? Whereas in rough surface, do you find your image in any fabric when you turn on the light?
No.
No, ma'am.
So I hope you got the concept of smooth and rough surface.
Yes,
So
ma'am.
any surface that is obtaining your image either clear or unclear, that is a smooth surface. So means pretty obvious that a mirror is a highly polished or highly smooth surface, because it obtains a clear image of ours, right? And any surface that does not form an image is the rough surface. That is because of irregularities on the surface. If you want to note this down, please do it.
I'm done.
Others?
Ma'am, done.
Okay. I'll stop sharing it because next we have to learn about the image formation in a plane mirror. Is it done?
Yes, ma'am.
Okay. I'm erasing it. Okay. Now imagine, or you can actually, if you want to stand in front of your mirror, that is in your home, you can stand and just observe carefully that what characteristics do you note in a plane mirror. If I ask the characteristics of image formation in a plane mirror, what those points will be?
It will be real.
What do you mean by a real image?
Real. Virtual.
Decide first if it is real or virtual. Okay, anyways, next point. Okay, does our size vary when we look into the plane mirror? Means if suppose my height is 5'4",
It is
so
a.
the height
It
of
will be of
image
the.
will be 5'2" or 5'6".
Ma'am,
It
it
will be
will
of the
remain the
same.
same.
It will be same. So the image obtained is of same size always, right? Next, if I'm wearing a blue color dress, so the color of image will be somewhat different, or red or yellow color?
It will be same.
Same, ma'am.
It will be same. Color will also be same. Uh, if I'm standing at 2 meters from the mirror, do you find the image also standing at 2 meters, or it is 3 or 4 or 1?
2 meters.
I expect the answer from other students as well.
Ma'am, same distance.
Ma'am, same distance.
Same distance. If I take 2 steps back now, like if I'm standing at 4 meters, how much by how much distance the image moves?
By 4 meters.
Hmm?
By 4 meters.
By 4 meters away only, right? Or towards?
Away.
Away. So means the speed and the distance also is same always. As far behind the mirror as the object is in the front of mirror. Virtual and erect. Now these 2 points. Let me tell you first erect. Uh, my head is up, my legs are down. So the image is the same way, or image appears like my head is down and legs are up.
Same, like
Same way.
it doesn't
Same.
Same
get
side,
inverted.
same side up is visible in the mirror, and whatever in the bottom, it will appear in the bottom only. So erect means when same side is up. Can you see my video also?
No?
Yes, ma'am.
Okay, actually, I want to explain something. Suppose this is the object. My left hand is the object, and my right hand is the image. So, image is obtaining the same way as the object is here, right? In some cases, in certain type of mirror, the image obtained is like that. Means object is, suppose this is a pen, tip is upside, and the base is here. The circular curved surface is here. The flat circular surface is here. So image will also be this way, then that type of image is erect. If the image obtained is that way, means upside is appearing down, then that is the example of inverted. So erect means when the same side of object is up. Same side is up, right? That type of image is erect image. Now comes what is virtual. So just for information, the opposite of erect is inverted. That in some cases, when the image appears upside down, that type of image is inverted. This is in uh, comparison with the erect. Okay. Now, what is virtual? See, if I'm standing in front of mirror, I see
A
the
virtual
image
image is like which cannot be bought on a screen.
which cannot be.
Brought on a screen, like the image
Yeah,
cannot be brought on a screen.
correct. Very good. Uh, I find my image in the mirror. Means if I disappear, something which is false, something which is pseudo, that is virtual, right? Let's say when you visit to watch a movie, that film is projected on a screen. Do you see that in some mirror? Do you see a movie in the mirror or on a screen?
Ma'am,
On
on
a
a
screen.
screen.
On a
On a
screen.
screen, no? So means the wall can act as a screen, the curtain can act as a screen, that white colored sheet, especially that you can find in the schools, colleges, institutes, etc. That is a screen. So any object that is obtained on screen is real, but that is not obtained, that is inside the mirror only visible, with that image is virtual. Okay, that cannot be formed on a screen. Is virtual, and the image that is formed on screen is real. So this real is in contrast to virtual. Please note these down. Note all these points. These all are the characteristics of image obtained by a plane mirror. Virtual means false image that is not obtained on screen. Erect, where same side is up. If my head is up, the head in the image is also up. If my legs are down, the image in the legs in the image are also down. That is erect. It is of same size always. It is at the same distance as that of the object. And last point we are going to discuss about lateral inversion. Noted all four.
Yes,
Okay. Last point comes. What is lateral inversion? If I raise my right hand, imagine from the image side, which hand the image raise. If I am raising my right hand,
left,
yeah. And if I raise my left hand, the image raises its.
right.
This you can,
Right.
this you can note by imagining yourself you are standing at a place of image. Then you can easily understand, right? So the right side appears left and the left side appears right. So there is inversion but horizontal inversion. Like my head is up, my legs are down. So this is not the case vertically that my image in the image I can see my head down and legs up. Only horizontally I can see the inversion. So that type of inversion is known as lateral inversion. So one of the characteristics of the in the image of a plane mirror is laterally inverted. You can write somewhere that in the image left appears right and right appears left, or I'm writing vice versa. Note the last point also. Noted?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Fine, fine, okay. But if I ask you to draw um, the image of a tree in a plane mirror, can you all do that?
Ma'am, image of a
Image of a tree in a plane mirror. You have to show
tree.
the, yeah. You can take a tree, you can take a pencil or anything, any object that is visible to you. You have to show how the image obtains in a plane mirror by the ray diagram.
Ma'am, by the ray diagram, ये ऊपर वाला diagram incident ray reflected ray वाला.
Pardon, please?
Ma'am, ray diagram, which diagram?
Okay. Anyone? No, hold on, let me share the whiteboard. Whiteboard visible to all, I hope.
Yes, ma'am.
This is our plane mirror. The shaded side is painted, okay, and the left side is reflecting surface. Left side is reflecting, and the right side is painted. Children, one thing that it's not a perfect straight line, but I request you all to use the ruler for this purpose, because otherwise if the measurements get wrong and if the lines are not straight, it will not look tidy, and actually the mirrors and all are always straight. Okay, let's take a tree. Please see carefully, step by step, how the image gets obtained. Let's suppose, see, first thing, the light is not a single ray. Light is not two rays. Light is not three rays. Light is always like a beam, right? But for studying purpose, for this purpose, we use ray, single ray, so that it becomes little easier to study this. So I'm taking one of the rays, suppose, is coming from the top of a tree and falling on the mirror. Let me take uh, this is the incident ray now. Now it becomes my point of incidence. At this point, if I draw a straight line that is a perpendicular normal, I think that this angle is somewhat about 25 to 30 degrees only, right? This is my angle of incidence here. This you do not have to draw, just understand first. Next, I'll draw the clear diagram. Okay, that's my incidence angle. Now the ray will go pass back, forming the same angle. You all please draw this properly by taking certain idea about the same angle. The bottom one I know is looking certain bigger from the incident angle. Now, if I take another ray straight, it is coming straight. So the angle of incidence is always measured with the surface, right? The surface on which the light is falling. The
Yes,
incidence
ma'am.
angle is measured with the surface, right? 10th class.
Yes, ma'am.
Are you sure? Is it really yes? Do we measure
Ma'am,
the
can you
angle with the
repeat?
surface? Huh?
Can you repeat?
The incident angle is always measured with the surface. So I should measure this angle, right?
Incidence, ma'am, it is measured with the normal.
Children, please focus, concentrate. It is measured with a normal. I told you this thing, keep this in mind. Incident and reflected angle never measured with the surface. These are measured with the normal 90-degree line. I think it's not so clear. Should I draw another diagram?
Yes, ma'am.
Okay, fine. See, feel free to speak because if we are not communicating openly now, there'll be doubts will be doubts. We have to clear all the doubts. So be open. This side is painted. Incident ray, normal. That's my angle of incidence. Okay. Sorry. This is my angle of reflection now. I and R. Now what you have to do is look at the reflected ray and produce it back with a dotted line, not the solid line. Produced it back. Now now where the image is obtaining, we need at least two rays to find a point where the image is obtained. Okay, so I'll take another ray straight. Can anyone tell me what is the angle of incidence in this ray, which I have just drawn this ray? Because here the normal will be this, coinciding the incident ray.
And then it will be 0.
Yeah, because see, if the normal is this, and light is also incident at this line only, means along the normal. So angle is measured with a normal. So normal and incident ray are coinciding. It means the angle of incidence in this case is 0°. Okay. 0° means the light will get reflected by making the same angle 0 only. So if it is incident here, it will reflect back on the same path. Got it?
Yes,
Yes, ma'am.
Right? So this time I have to produce back the reflected ray. I'm producing it back. And see, I have got the point. This is the point where the two reflected light rays strikes behind the mirror. Okay, because this is going behind the mirror, that's why I'm drawing dotted. Now, from which point I took the light rays? From the top of a tree. Okay, so this point obtains the image of top of a tree. Fine. Now, why I'm drawing this complete tree? Because if you will take the beam of light or if you will take multiple rays in such a way, finding incident angle, reflected angle, you will find the proper complete image of a tree this way only. And similarly, you can draw the bottom part. Got it? If you will do the same process, the two rays you take from the bottom, you will find the image of the bottom, this base of tree also. Any doubt in this?
No, ma'am.
See, let me write some steps so that you can remember how to draw, because the question may arise in board exam that a pencil is given, or you are asked, you are supposed to draw the mirror image formation. This can be of 2 to 3 marks with a proper label diagram. So first step is to draw the mirror, draw the object. Next, take a ray with certain angle, take incident ray with certain angle. Okay, draw the reflected ray. Now next step is reflected ray you will draw with the help of the normal. Now produce back the reflected ray. produce back the reflected ray. Take another ray with the 0-degree angle. Angle I is equal to 0. So angle R will be equal to 0. Now produce it back again. Produce back the reflected ray again. And you will get a point. That point will be the image of the same point where you took the rays coming out from. Like here we took the top of a tree. So these are certain steps that you can just remember, and you can draw the image of any object. Please draw this diagram using a ruler. Draw this diagram quickly. Instead of taking the screenshots and clicking picture, try to note everything. Because it's true that whatever we write, it can be retained very easily.
Ma'am, written.
Noted?
Ma'am, one. I'm done.
Okay. Note this as a homework. See the two laws of reflection. Second, show the image formation of a pencil in the plane mirror.
Ma'am, noted.
Ma'am, this is
All
the
noted?
homework, right?
Right. Yeah. Uh, Gagandeep, if I'm not wrong, can you state the characteristics of image that is obtained in a plane mirror?
Ma'am, can I say?
No, I mean, wait. Please unmute yourself. Sudhanshu, you don't unmute yourself, Sudhanshu. Zoha,
Yes, ma'am.
yeah. Characteristics of image.
Ma'am, it is virtual,
Hmm.
erect,
Hmm.
laterally inverted. It's of the
Okay.
same size as the object,
Okay.
and the distance is also the same.
Okay. One more question I want to give it to you. Hold on. I'm putting in the chat. Calculate. This one is the third question. Okay, I'm putting in the chat. Please note down. Calculate the total angle between incident ray and reflected ray if the angle of incidence is 45 degree. I posted this question in the chat. Calculate the total angle between incident ray and reflected ray if the angle of incidence is 45 degree.
90 degree.
So 3 questions in all, right? So we'll meet tomorrow again and we'll study about the spherical mirrors, right?
Okay, ma'am.
Do the homework positively, and the more you communicate, the more our doubts will get clear, the more physics will become easy. Physics is not typical, as students say usually. It's simple if we understand it. And speak openly, say openly anything you want to say. If you are wrong, that is okay. We were also at that stage. We were also wrong at some point. Okay, means our teachers corrected us, and that's our duty now, right? So don't hesitate, be open. Okay, thank you. Bye bye, everyone.
Okay, ma'am. Bye.
Mm.